Now let's talk about piecewise functions. A piecewise function is a function that comes in pieces. Each piece is a formula that is bounded by a certain interval. So in this example 6, you can see that a piecewise function f of x includes 3 different formulas, and each formula is bounded by a different interval. Let's look at the first type of problem. Evaluate f of -3. In this case, x is -3, so we need to look for the formula that has the interval that contains -3. So -3 is a number that is less than -1. Therefore, we are going to be using the first formula, -x minus 1, to evaluate the function. So we have -x, so that will become -3 minus 1. -3 gives you +3 minus 1, and that equals 2. Part B, f of -1. Where is -1? -1 will fall in this interval here because here x can equal -1. So therefore we are going to use the second formula, which is -3. Without x being involved, we're just going to write f of -1 is equal to -3 no matter what. As long as x is between -1 and 2, f of x is always -3. Part C, f of 6. f of 6 would fall into this interval because 6 is the number that is greater than 2. So therefore, we are going to be using square root of x minus 2 to evaluate this function. So we should have square root of 6 minus 2, which is square root of 4, which equals 2. Now, how do we graph this piecewise function? We are going to graph each individual function, and then we're going to only keep the part that falls within certain intervals. So let's see how it's done. First, I am going to graph -x minus 1. This is going to be a straight line. Imagine that this is a function itself. It is already in slope-intercept form. You can see that the slope is the coefficient in front of x, which is -1. Make it -1/1, then you can see that the pattern here is down 1 unit and to the right 1 unit. And the y-intercept is the point 0, -1. So let's graph that line. 0, -1 is here. Then we want to go down 1 and to the right 1. Or you could also go up 1 to the left 1. Now we connect these dots, and we should get the graph of -x minus 1. But because of the condition for x has to be less than -1, strictly less than -1. So here is where x is equal to -1. So it looks like we can only accept the section of the line that is to the left of -1, which is this section right here, to the left of it. So I'm going to erase the rest of the line and only keep the green part. Furthermore, in this case, x is strictly less than -1, so we cannot have a solid dot at the end where -1 is. We are going to put an open circle here. I will go ahead and put an arrow here since the line will go on forever to the left. So there's the first piece of the graph. Second piece of the graph, we have f of x is equal to -3. When you have y is equal to a constant, you should expect a horizontal line. So this horizontal line will go like this. But where is it bounded? It's bounded between -1 to 2. So -1 is here and 2 is here. So we can only keep this middle section that is in between, and we are going to erase everything else. So there is the second piece of the graph. Now, x can equal -1 here, so I'm going to put a solid dot here, indicating that -1 is included, but x cannot equal -2, but x cannot equal 2 because it says x is strictly less than 2. So I'm going to put an open circle right here. And then we have the third formula. We have square root of x minus 2. This is a square root of x function that is being shifted to the right 2 units. So some of the main points for the square root of x function is 0, 0, because the square root of 0 is 0. 1, 1, because square root of 1 is 1. 4, 2, because square root of 4 is 2. So if you shift the function to the right 2 units, that means you are going to keep all the y values the same, but you will add 2 to all the x coordinate. So you'll end up with 2, 0, 3, 1, and 6, 2. So let's plot these points. So 2, 0, 3, 1, 6, 2. So the graph will look like this. This formula is applied to where x is greater than or equal to 2. So here's where x is equal to 2. Greater than means anything to the right of that 2. So we do accept this whole curve that we just drew because it's already to the right of 2. In addition, x is greater than or equal to 2. So that means we should put a solid dot here to indicate that 2 itself is included. And there you have it. That's a graph of this piecewise function.